As languages evolve, it becomes clear that certain patterns are really the way to go. So, for example, with Rust, it comes with cargo. Cargo has everything you need: cargo format, cargo build, cargo clippy, etc. Likewise, if you want to use Deno and have this really amazing runtime, it already has all of the utilities that you need built into it. So Deno run, Deno format, Deno lint, Deno test, Deno compile, Deno check, Deno REPL. And it's really exciting because you don't have to do all kinds of weird configuration. It comes with the runtime for Node and TypeScript. Let's go ahead and take a look at this first command here, Deno run. This is V8 snapshot deserialization. This means that you can have a bootstrapped runtime that is able to reduce cold start. So you can get really fast, like 2 millisecond start times with Deno run. It also has capability-based security, which is really interesting because it means that you can turn on permissions to the file system or the network, etc. And this is really great for security, and it can even be built into the compiled binary. And we'll get to that in a second. There's also module graph construction inside because it uses Rust's pet graph. Now let's take a look at Deno format here next. Deno format is really nice because it has this contract that allows you to have a very efficient white space comment formatting, and it's able to give you, let's say, 10,000 or so lines of code at a time, and able to scan those tokens and format it. It can do caching as well, so it's able to use hashes that are stored in SQLite through O1 format checks, so it can get a 95% cache hit rate in monorepos because it's doing incremental file hashing. And then also has parallel IO saturation with Tokyo file system. So really sophisticated architecture for linting. And then if you look at Deno lint here, this is a single pass architecture. It uses Rust's parser to achieve really high throughput, also graph analysis, and then it has a just-in-time compilation. Deno test is pretty cool because it comes in with your whole test suite. Again, you don't have to do some kind of weird installation for tests. It has a V8 profiler as well. It has deterministic parallelization. And then if we go to Deno compile, probably my favorite of all the commands is that it's able to have the ability to compress things, statically link so that you get this nice binary. And also you have heap snapshot embedding. So the V8 heap snapshot is embedded inside as well. So really cool that you can get all this security and improvement with speed. And if you just do Deno compile, it gives you a binary, you can run it. Now Deno check is able to use this TypeScript checking. So it's able to verify that the TypeScript compiler works with your code, check for any kind of errors. And then also we can wrap up here with Deno REPL. And the Deno REPL is also pretty interesting because a lot of people like REPLs. I mean, it's nice to be able to try ideas out, etc. So the Deno REPL allows you to play around with code and really get a feel for long-lived isolations with a 50 megabyte initial heap, and you get just-in-time optimizations throughout, and then you get top level of weight support as well. So you can get this async, micro task queue draining between evaluations. So really snappy ability to use the REPL. And then in terms of Rusty line integration, it's able to use Rust itself and Rusty line crate for readline functionality. And so it has a persistent history as well through ~/.deno REPL history. And this is allowing you to implement a TypeScript aware tab completion via the TypeScript language service. So really cool architecture here with the Deno subcommands. And I think that's probably the thing that is so compelling when I look at Deno. If you have to use TypeScript, in many cases you do, it is a very compelling scenario to then take a look at Deno and go, wow, I have all these built-in tools. It feels a little bit like Rust. Let's go ahead and try Deno as my go-to runtime for building things with TypeScript.